Welcome back to the course, guys. Hope you have your tea or water with you, or coffee if you prefer. So we're going into lecture number 5, the evolution of database and database management system technologies. Let's get into it. Learning objectives for this lecture. What is a database? What is a DBMS? We're going to go through a timeline. I'm excited for that. And then I'm going to give you my future prediction of where I think DBMS technology is headed. So I think this is a critical question to answer. And what is a database? So if you look in the realm of computing, a database is effectively a storage of data. We can access this electronically. Simple definition. And this is my definition, so I'm open to interpretation for this. But effectively, a database is, you could argue that it's a collection of tables. And if we want to visualize what a table is looking like, we can see this example here, first name, email, created at. And more specifically, it's important to note that the columns are on the vertical axis and the rows on the horizontal axis. That's a key distinction that we should be making. And that's just a basic definition of what a database is. If we move on to now, what is a DBMS, standing for Database Management System. So this is my pretty picture here. So from what you can already gather, a DBMS is just a management system effectively. And there are multitudes of softwares out in the marketplace these days. And these are some of the heavy hitters. So we can see MySQL Workbench and Postgres QL, SSMS, which is what we're going to be working with, and Oracle. These are the 4 main big databases, and there's a lot different type of DBMS vendors out there. Okay, so this is going to be an interesting part of the lecture, the history of the DBMS and DB technology. You may be quizzed on this, so it's just good to maybe take some notes. Okay, so as you can see here, I've started the timeline quite early. To be exact, 3200 BC. And I think it's an important distinction to make that the concept of databases, or the concept of recording data in some sort of organized format has been around for years. If we actually look back in time and see how these ancient people recorded data, it was all on ledgers. And you can make the argument that in the strict sense, a ledger is not the same as a database, but they both hold similarities. And that's the reason why I wanted to demonstrate this time in history. So as we can see here, over 5,000 years ago, the ancient Mesopotamians started to record quantities on clay tablets. And I think that's an interesting point to make because it really establishes the foundation of this idea in our head to record data as humans. So I thought I would put that in. Fast forward, not much has happened between 3200 BC and 1960s. But as we see here, this is when the emergence of modern day databases really starts to come to fruition. The Oxford Dictionary Cites database in 1962. IBM hits the scene and they developed the Guam method for the Apollo project, which is quite interesting. We see General Electric jumping into the mix here, and they developed what's called the IDS, their own take on a DBMS. So the 1970s was a decade filled with a lot of activity, and it all began through one man, and you can call him a pioneer in the database world, and this is Edgar F. Codd. And he published a paper on relational database concepts in the early 1970s. And he drew on concepts from mathematics. He himself was a mathematician and an F1 fighter pilot. So he had quite a decorated background. And he published this paper, which drew on mathematical concepts, calculus, and these such things. As we can see, in approximately 1974, the emergence of SQL or SQL, depending on how you want to pronounce that. This was in the early stages. It started to emerge and it was developed by IBM and developed specifically by Donald D. Chamberlain and Raymond F. Boyce. after learning about the relational model that COD had offered. In the meantime, simultaneously, we can see IBM starting to develop their own DBMS project called System R. And we'll later find out about that. And in 1975, the University of California, Berkeley, developed Ingres, which is another DBMS, and had the base language called Quell. I guess the overarching theme in the 70s was obviously COD's paper, but also seeing the battle between Oracle and IBM to release their first DBMS to mass market. And it's interesting because Oracle beat IBM to the punch. They beat them to the punch by a full 2 years. And this was quite a big time for database management systems. And Oracle really made a name for themselves in this time. In 1979, they first released their relational DBMS. And then IBM didn't start shipping its system until 1982. So they were a bit behind the 8 ball. Obviously now we have so many different versions of database systems. I actually want to show you this website. It's called Database of Databases. And we can see the total number of databases created in America as of today is 409. Germany, China, United Kingdom. And this is quite a fun website to have a look at and just geek out on the stats. So yes, we are inundated with a huge selection these days. And back to the timeline. So if we progress to the 1980s, not as, I guess, in relation to the 70s, it wasn't as much activity. We can see another DBMS hit the market called Ingres, no relation to Postgres SQL. And 1985 saw the battle of the three giants, Oracle, Ingres, and IBM. And one would always claim they had more installations over the other, but each company publicly stated they had 1,000 installs. So they may have been contracting for other organizations and they've approximated 1,000 installs each. So I guess there was some battle to have who could have the most installs. So I've blended the 1990s to today. We're in 2022 of April. And if we look at 1990, DBMSs were implemented with the flavor of object-oriented programming. This was a popular concept. And why wouldn't they? So this is for efficiency. But then I guess this was a really big breakthrough. 1998, the concept of no SQL or not only SQL had given birth. And this leads me into my last point, and this is really the future of DBMS / database architecture. And 2050 is a bold 28 years away from where we are right now. And to be honest, I can't really give you an accurate prediction. All I can say is as technology improves, as cloud computing improves, we'll see obviously an uptake in performance. With the metaverse and Web 3.0, it's interesting space to see how databases will adapt to this new environment. So thanks guys, that's been the history, and thanks for watching this lecture, and I hope to see you in the next lecture. Thank you.